Let us study about electric generator. An electric device which converts mechanical energy into electric energy is called an electric generator. Principle: electric generator works on the principle of electromagnetic induction. When the coil of electric generator rotates in a magnetic field, the magnetic field induces a current in this coil. This induced current then flows into the circuit connected to the coil. Types of electric generator: AC generator, DC generator. AC generator: a generator which converts mechanical energy into electric energy in the form of alternating current is called AC generator. DC generator: a generator which converts mechanical energy into electrical energy in the form of direct current or DC is called as DC generator. AC generator construction. The main components of AC generator are as shown: armature, strong magnets, slip rings and brushes. Armature, strong magnets and brushes are the same as used for electric motors. Slip rings. The two ends of the armature coil are connected to two brass slip rings R1 and R2. These rings rotate along with the armature coil. Working. When the armature coil ABCD rotates in the magnetic field provided by the strong magnets, it cuts the magnetic lines of forces. Thus, the changing magnetic field produces induced current in the coil. The direction of induced current is determined by the Fleming's right-hand rule. The current flows out through the brush B1 in one direction in the first half of the revolution and through the brush B2 in the next half revolution. In the reverse direction, this process is repeated. Therefore, the induced current produced is of alternating nature. Such a current is called as alternating current. DC generator or dynamo. Construction. The main components of DC generator are: 1. Armature coil, 2. Strong magnets, 3. Split rings or commutator, 4. Brushes, 5. Bulb. The components such as armature coil, strong magnet, brushes are the same which are used for AC generators. Split ring or commutator is the same as used in electric motor. 5. Bulb. The output is shown by the glowing bulb connected across the carbon brushes. Working of DC generator. When the coil of DC generator rotates in the magnetic field, potential difference is produced in the coil. This gives rise to the flow of current. This is shown by glowing of the bulb. In DC generator, the flow of current in the circuit is in the same direction as long as the coil rotates in the magnetic field. This is because one brush is always in contact with the arm of the armature moving up, and the other brush is in contact with the arm of the armature moving downward in the magnetic field. Students, try to draw a sketch diagram of electric supply from your electric meter to any room in your house. Let us look at the domestic electric circuit. State Electricity Board provides us with the electric power supply for houses and factories. This is supplied through underground cables or overhead wires on poles. These wires or cables are of three types: phase wire or live wire, neutral wire and earth wire. These wires coming from power substations are connected to an electric meter installed in a house or a factory. The potential difference between the live wire and neutral wire is between 220 volt to 250 volt. The output power from electric meter is taken to the main switch. A fuse known as main fuse is placed in the path of live or phase wire. The output electric power from the main switch is distributed to the domestic electric circuit. This shows a schematic diagram of one of the common domestic circuits. In each separate circuit, different appliances can be connected across the live and neutral wires. Each appliance has equal potential difference. They are connected parallel to each other. What are the safety measures to be taken in using electricity? Electric fuse. An electric fuse is a safety device used to save the electrical appliances. Wires carrying electricity should not be touched barefooted. If we touch the wire barefoot, a large current may pass through our body, so we may receive severe shock. This shock may sometimes cause death. Therefore, while working with electricity, we must wear gloves made of insulated material and rubber-soled shoes so that current may not flow through our body. The insulation of the wire must be checked periodically. Earthing. Many electrical appliances have a metallic body such as electric heater, toaster, oven, refrigerators, etc. If by chance insulation of the wire melts, the live wire may touch the metallic body of the appliance. If we touch this body with bare hands, we may receive a severe shock. To avoid such accidents, metal casings of all electrical appliances must be earthed. One end of a copper wire is connected to the metal case of the appliance and the other end is connected to the copper plate which is buried deep inside the earth. This system of connecting the metal casting of an electrical appliance with a copper plate buried deep inside the earth is called as earthing. Electric circuits should be switched off during lightning. This will save the electrical appliances from burning. What is meant by short-circuiting and overloading? Short-circuiting. If a live wire and a neutral wire come in direct contact or touch each other, short-circuiting takes place. During a short circuit, the resistance of the circuit becomes very small and hence huge amount of current flows through it. This produces a large amount of heat and raises the temperature. As a result, the circuit catches fire. Overloading. Overloading means the flow of large amount of current in the circuit beyond the permissible value of current. If many electrical appliances of high power rating such as geyser, heater, motor, oven are switched on simultaneously, overloading occurs. This causes fire. This can be avoided by not connecting many appliances in the circuit.